All right. So tonight, like I said, we're going to cover 6.3 and 6.5. 6.3 is complex fractions. Okay. I also teach high school math, and in my classes, I don't want to say it's a fun lesson to teach, but I do a couple of things that at least I think are funny. So complex fractions are fractions inside of fractions. So you'll have a fraction numerator and you've got a fraction denominator. And I jokingly say that in math, fractions are the math F word. And if fractions are the F word, then this is a mother fraction. Okay, so if you've got a fraction on top of a fraction, okay, this is like some people's worst nightmare. Okay, when it comes to complex fractions, you have two methods to simplify these, and that's what the instructions are going to ask you to do. They want you to simplify this. Okay, fractions on top of fractions is not simplified. This is complex. The easiest way to do this, when you have one fraction over one fraction, the easiest thing to do is to actually look at this as a division problem. So 1/2 over 1/3 is quite literally the same thing as saying 1/2 divided by 1/3. So when you have just one fraction over another, this is really the same thing that we did last time. Remember, division is really just multiplying by the reciprocal. So if we take 1/2 times 3 over 1, 1 times 3 is 3, 2 times 1 is 2. So this 1/2 over 1/3 simplifies to 3 over 2. That is the easiest way to do this when you have just one fraction over another. Now, that won't always be the case. So I'm going to walk through another method for solving these, or simplifying, not solving, I apologize. It is simplifying. But one thing we can do with complex fractions is we can multiply everything by a lowest common denominator. So again, if I look at my denominators of 2 and 3, okay, that lowest common denominator, 2 and 3 both go into 6. So if I multiply this by 6 over 6, which is essentially a 1, you know, same number on top and bottom, it's a 1. That's going to give me an equivalent fraction. It's not going to change anything. So if I multiply 6 times 1/2, okay, 6 times 1/2 is like saying 6 over 1. So we can multiply, that would be 6 over 2. 6 divided by 2 is 3. Same thing, 6 times 1/3. It's like 6 over 1, multiply, we get 6 over 3, which is 2. Okay. Again, same answer, kind of two different methods. Now, this lowest common denominator method works really well whenever we've got some addition and subtraction going on inside of the mother fractions. Okay. If it's just one fraction over one fraction, you can multiply by the reciprocal and everything cancels out really nicely. Okay. When we've got any kind of addition and subtraction, we pretty much have to do it this way. You don't necessarily have to, but it is the easier method. So it's typically not just going to be pretty little numbers. When it's this case, you can actually just punch that into your calculator, and most calculators will spit out the right answer, but they're going to start throwing in variables. So you're going to get problems like so. Okay, again, we've got a fraction over a fraction. Now, there's no plus and minus happening here. So this is one that we can do that multiplying by the reciprocal. And in fact, that's an easy way to do this problem. Okay, if we divide, okay, this top fraction stays. Division, we change to multiplying by the reciprocal. So again, when we reciprocal this or we flip it over, that 2y that's on the bottom goes to the top, and that 3x squared on the top goes to the bottom. So again, division is multiplying by the reciprocal. Now, again, multiplying, this goes back to the lesson that we did last time. We can cancel common factors. So as long as we're multiplying, which we are, we can cancel factors that are the same on the top and on the bottom. So for example, those two y's essentially cancel each other out. And same thing, 15 could be the same as written as 3 times 5 times x. 3x squared is 3 times x times x. So again, common factors. So everything cancels except for that 5 in the numerator and one of those x's in the denominator. So fraction over a fraction, multiply by the reciprocal. Now, like I said, they're going to start throwing in some plus and minus stuff. When they do that, okay, now it's not as easy to just multiply by the reciprocal. This is one of those problems where multiplying by that lowest common denominator is going to be a better method for solving. All right. Now, one thing we can do here, and I'm going to go ahead and do this. I want everything to have a denominator. So when I just see this whole number of 1, I'm going to give it a denominator. Whole numbers you can just put over 1. So again, our method for this one is we can multiply everything by a lowest common denominator. So if we look at all of our denominators, we need something that all of those go in to. So we've got a 9, an x, a 1, and an x. So we can multiply by 9x. 1 goes into 9, 9 goes into 9, x goes into 9x, x goes into 9x. So that covers everything. Now, when you multiply, again, you got to distribute here. So 9x times x over 9 is 9x squared over 9. 9x times x is 9x squared over your denominator. 9x times 1 is 9x over x. And again, now we can simplify that. So 9 over 9 cancels out to 1. So that's just x squared. The x's cancel, and then that's just 9. Ooh. Same game, if we multiply here, 9x times 1 is 9x. 9x times 3 over x is 27x over x. And again, those x's cancel, so we get 9x minus 27. So that gets rid of our complex fractions, but again, the instructions told us to simplify. So we need to see if there's anything else we can simplify out of this. Now, if you remember from the very first lesson, to simplify, again, we need common factors. When you have plus and minuses, you can't just cancel x's and 9s, okay? We were able to cancel 9s before because, again, this is a multiplication problem. All right, we can cancel our x's here because that's multiplication. Here we can't cancel because it's addition. So I'm going to factor, so x squared minus 9 factors into x plus 3 and x minus 3. That's this one. That 9x minus 27, we can factor out a 9. And now because we're multiplying, we can cancel those common factors, leaving me with a final solution of x plus 3 over 9. So this big, hairy, ugly thing reduces all the way down to x plus 3 over 9. Okay, I'm going to do two more examples of similar types of problems. The next two problems I show you is kind of as, like in my mind, as ugly as it gets. So that's similar to this. So there's a lot of things going on. So something to pay attention here. I get it, it's a lot, but anything you can do, okay, is progress here. This is a problem like this is going to be worth a number of points, probably 4 or 5 points. So I need to see these intermediate kind of steps so we can get there. All right. All right. Like I said, I'm going to do two more examples. All right, so we've got x minus 1 over x squared minus 4 over 1 plus 1 over x minus 2. Same thing, I still want to make that have a denominator. Another thing that will help here is, again, when we're simplifying or talking lowest common denominators, if we can factor, that is typically helpful. For example, that x squared minus 4 can be rewritten as x plus 2 and x minus 2, which helps because if we're looking for a lowest common denominator, we just have to make sure that everything gets covered. So if we're looking, we've got an x plus 2, an x minus 2, an x minus 2, and a 1. So our lowest common denominator is x plus 2 and x minus 2. So if we multiply, we get x plus 2, x minus 2, and x minus 1. So these two and this all over that x plus 2 and that x minus 2, which again, since we're multiplying, those factors cancel out, leaving me with x minus 1 on the top. Same game to the bottom. If we multiply, x plus 2 times x minus 2 times 1 is just x plus 2, x minus 2. Okay, same if we multiply that. We get x plus 2, x minus 2 over x minus 2. Since we're multiplying, those cancel. All right, we kind of need to clean this up. So we've got a lot of things going on here. We can't combine all of these things. We can go ahead and multiply those together. So here, let me keep this. So we've got x minus 1 on the top. We've got this x plus 2, this x minus 2, and then plus another x plus 2. So I'm going to try and see if I can clean up this bottom here. So if I FOIL this out, I get x squared minus 2x plus 2x goes away, and then minus 4, okay, plus x plus 2. So we end up with x squared plus 1x and then minus 2. Now, this might simplify still, so we need to look and see if we can do anything else with this. So once we've combined all of our like terms, we can see if this particular problem factors. X squared is x times x. Is there anything that multiplies get negative 2 that adds to get 1? Yeah, positive 2 and negative 1. So again, now we've got common factors. So this reduced all the way down to 1 over x plus 2. Okay, that is about as ugly a problem as you are going to see. This has a million different things going on. Okay, we've got a factor to find that lowest common denominator. We multiply and cancel factors. Clean up the bottom. Factor, cancel common factors again. Simplified answer. Okay, this is as ugly as it gets. I'm going to do another example that's about like it. And then we'll move on to 6, 5. All right. So 25 x squared minus y squared over x y over 5 over y minus 1 over x. Okay. Again, we want to get rid of our common denominators. If we start looking at our denominators, we've got an x and a y and a y and an x. So in an xy, we'll cancel, get rid of our denominators. So if we multiply here, get xy times that 25 x squared minus y squared over xy. So those will go away. Multiply here, we'll get 5xy over y minus 1xy over x. Again, this is all multiplying, so those y's cancel. Leaves me with a 5x. Those x's cancel, leaving me with a 1y. Again, I need to see if I can simplify. 25x squared minus y squared, those are perfect squares. So that factors into 5x plus y and 5x minus y over at 5x minus y. So those cancel, leaving me with 5x plus y. So big, hairy problems that reduce down to next to nothing. Okay, I believe there are 9 problems like that in your My Math lab. Got to practice. Okay, if you need to go back and watch the videos, I'll have the video from last year posted as well as the video that we're making right now. That gives you a few examples to look over. You can slow down, hopefully kind of follow what I was doing as far as the notes go. Make sure you practice these kind of problems. Okay, the last thing that we're going to cover, okay, is section 6.5. And 6.5 is all about solving rational equations. So 6.1, 6.2, 6.3, we're all about simplifying. Okay, simplifying was a lot of, canceling, factoring, finding stuff that cancels out, ending up with some fractional expression answer. Okay, 6.5 is all about solving. So some of the stuff we're going to do here looks kind of similar, but don't forget there's a difference between solving and simplifying. Okay, when it comes to solving, again, we're looking for a solution for x that will make this work. In fact, a problem like this, we've already done. We did problems just like this on the very first test that we ever took. In fact, the very first lesson we ever did had a problem that was almost exactly like this. Okay. The difference between what we were doing before is now we have an equal sign, right? So we can solve. We're looking for what number can I put in here for x that makes this whole thing equal out. Okay. The easiest way to solve rational equations is, again, to get rid of the fraction. We want to make it not rational. So again, look at that common denominator. So if we look at our denominators, x and 2 and 3, we want to multiply everything by whatever these go into. For example, 3 and 2 both go into 6, and we need that x. if we multiply 6x times 3, we get 18x over x, which is just 18. We multiply 6x times 1 over 2, we get 6x over 2, which is 3x. We multiply 6x times 1 over 3, we get 6 over 3, which is 2x. So again, if you multiply by that lowest common denominator, we can get rid of the fractions. Once we get rid of the fractions, this is just a basic linear algebra problem. Get your x's on the same side. Divide, divide. X is negative 18. Now, the good news is with an equation, you can check your solution. We can actually plug that negative 18 in, use our handy dandy calculator and see if it equals 1/3, which it does. So you can check your solutions to an equation. That's a nice thing. Okay. We do a similar problem. Okay, x plus 8 over, whoops, gotta raise this up where you guys can see what I'm doing. So x plus 8 over x plus 5 minus 3 over x plus 5 equals 0. Again, we want to multiply by a lowest common denominator. If we look at our denominators, our lowest common denominator is that x plus 5. Oops. So we're going to multiply everything times that x plus 5. Now I'm going to kind of shortcut this. I've been showing that when you multiply, you write it on top and then divide. You could actually shorten that, like the x's are going to cancel each other out. So all we need to do is take 6 times 3. We can jump straight to that 18. So same thing, 6 divided by 2 is 3. So that's where that 3x comes from. So if we do this here, if I multiply, you're going to have an x plus 5 on the top and an x plus 5 on the bottom. So those are going to cancel, leaving me with just the x plus 8. Same, if I multiply here, I'm going to have a negative 3. I'm going to have an x plus 5. So the only thing left is that negative 3. Anything times 0 is 0. So multiplying by that lowest common denominator got rid of our fractions and makes this a relatively easy problem to solve. Combine like terms, 8 minus 3 is 5. Subtract 5 from both sides, x could equal negative 5. Now, this is extremely important, okay? Also, the very first lesson in this chapter, we talked about restricting the domain. There were certain numbers that you could not have in your domain. This is one of those situations. So if we look, we solved everything correctly. We did all of the math right. We got a solution of negative 5. Pay attention though, what happens if I go to check my solution? If I plug negative 5 in for my x's, negative 5 plus 5 is 0. Remember, we cannot divide by 0. 0 can't be on the bottom. 0 on the bottom is bad. Okay, that bottom cannot equal 0. So if your solution causes your denominator to be 0, then this is not a solution. So in this case, there are no numbers that you can plug in for x that will work. This particular equation has no solution. Okay, We solve to get x is -5, but wait a minute, x can't be -5. That causes division by 0. Okay, if I go back and look at this problem, -18 is perfectly fine. If we go to plug it in, we will solve this and everything equals out. It all works like it's supposed to because there's no division by 0. So always check to see, does your solution cause division by 0? If so, then it is not really a solution. It's extraneous. We got to mark it out. And if you have no other solutions to worry about, then there is no solution. This problem is technically unsolvable. There are no values for x that would ever make this work. Okay, we got 3 more examples we're going to do. Okay, 1 over x minus x over 64 equals 0. Same game. We want to get rid of our fractions. Looking at our denominators, our common denominator is going to be 64 and x. So we're going to distribute that to everything. So 64x times 1 over x is 64. Your x's cancel here. We multiply 64x times x divided by 64. We get a negative x to the second because the 64's cancel. X times x is x squared. Anything times 0 is 0. Now, when you get an x to the second power and you've got to solve, this goes back to the last unit. Okay, this is a quadratic. Remember, when solving quadratic, we don't want to try and isolate the variable because sometimes that doesn't work. So we got to solve this by factoring or the quadratic formula. Okay. In this case, this one factors really nicely. 64 minus x squared factors into 8 minus x or 8 plus x. So we can set our factors equal to 0. And x could equal 8. Or x could equal -8. Okay, remember, when you have a quadratic and you solve by factoring, there's always the potential for 2 solutions. Sometimes they repeat, sometimes they don't. But anyway, in this case, neither solution caused division by 0. If we wanted to check our solutions, they actually both work. So +8 and -8 are both valid solutions. Now, you can write this a couple of different ways. I would just leave them separate. They're 2 different numbers. You can write them both. In my math lab, they want you to write it in a set, which you can do individually. Or if you just like writing shortcuts, remember, you can say plus or minus 8. That means the same thing. So that's just a notation, a thing about how the answers can look. I'm definitely more concerned with you being able to solve and get the correct solutions. All right. Similar example. Okay, in my mind, a problem like this is probably the ugliest problem you're going to see as far as this section goes. Again, this is the one where we've got the most different kinds of things going on that we all have to pay attention to. All right, again, just like with simplifying, just like with the complex fractions. Okay, when we're looking for a common denominator, sometimes it is helpful to factor. For example, that x squared minus 9 can be rewritten as x plus 3 and x minus 3. which again, that's helpful because when you start looking for a common factor, x minus 3 is a common factor, but we also need that x plus 3. So if we do x plus 3 and x minus 3, that covers all of our denominators. So if we multiply here, the x plus 3 and the x minus 3 both cancel, leaving me with 36. If we multiply here, nothing cancels, and we get x plus 3 times x minus 3 times 1, which is x plus 3 times x minus 3. If we multiply here, the x minus 3's cancel, and you're left with 2x times x plus 3, which no longer has fractions, but is still kind of ugly. So if we want to solve, we need to get to where we can combine like terms. So we've got our 36. This x plus 3, x minus 3, we need to refoil that together. So that's x squared minus 3x plus 3x minus 9. We distribute here. That is 2x squared plus 6x. All right, again, we have quadratics. We have an x squared, so we need to try and get everything to one side. So I'm going to move everything over. So I'm going to subtract the 36 from both sides. I'm going to subtract an x squared from both sides. I'm going to add a 9 to both sides. So I'm going to move everything over to here. 2x squared minus 1x squared is 1x squared. 6x doesn't have any like terms, so it's just a 6x. Negative 36 and positive 9 is negative 27. Okay, again, to solve a quadratic, we got to solve by quadratic formula or factoring. This one factors really nicely. X squared, again, is x times x. When there's no leading coefficient, your leading coefficient is 1. We need to figure out what multiplies to get negative 27, that adds to get 6, like positive 9 and negative 3. Set our factors equal to 0 and solve. X could be negative 9, or x could be positive 3. So that was our original problem. These are our potential solutions. Again, what do we got to look for? Make sure we don't have something that causes division by 0. For example, if we go to check 3 as a solution, what happens if we plug 3 into this particular x? You got to plug 3 into all of the x's, but 3 minus 3 is 0. This one causes division by 0. This is a bad or extraneous solution. 3 does not work. However, assuming we did all of the math right, if I plug in negative 9 minus 3 is negative 12. Okay. Negative 9 squared is 81. 81 minus 9 is 72. So that doesn't cause division by 0, assuming we did the math right. Negative 9 is a valid solution. Okay, just so you can see it, I will do one more example. It kind of plays out similar to that problem, but we'll do one final example. Okay, 1 over 2x minus 1 over x plus 2 equals 1 over 2x squared plus 4x. Again, when it comes to finding that common denominator, I want to factor anything I can. For example, 2 and x doesn't really factor anything. X plus 2 doesn't really factor, but 2x squared plus 4x, I can factor out a greatest common factor. These are all divisible by 2x. So that 2x squared plus 4x could be rewritten as 2x times x plus 2. Which is helpful because again, now if we look at our common denominators, 2x and 2x, x plus 2 and x plus 2. So our common denominator is 2x and x plus 2. You multiply, those two x's cancel. That's going to leave me with x plus 2. You multiply, the x plus 2's cancel. That's going to leave me with 2x. We multiply, the 2x and the x plus 2 cancel, leaving me with just 1. Okay, this is just a x, not an x squared linear equation. So all I got to do is combine like terms. 1x minus 2x is negative 1x. Subtract 2 from both sides. Divide. X is 1. 1 does not cause division by 0. Again, if we wanted, we can plug R1 in and see if we have a valid solution, which we do. X is 1. All right, so that finishes up chapter 6. Now that I have everybody in here, I do want to just reiterate. We will not, we will test next week. So this finishes chapter 6. That's the last lesson. You have next week to do your My Math Labs and turn those in. That's pay attention to your due dates in My Math Lab. But you are testing next week. Again, test is pencil and paper at your testing sites. Just like you did for the first 2, you've got to set up an appointment. You've got to go in. You've got to take the test. You've got to allow probably hour and a half to take that test. Make sure you're ready to go. Some of you struggled with getting that done in a timely manner. Don't be that way again. You know you have next week to test. Get it taken care of. Okay. Also, next Thursday, we are still having class. So maybe you test next Friday, that's fine. We still are having class on Thursday. I have to cover 7, 1, 2, and 3. I've got to cover those 3 sections. So test is next week over chapter 6. It is just those 4 sections. So we are testing again over 6.1, 6.2, 6.3, and 6.5. There was only those 4 sections, so it's not a huge test, but the problems involve ugly fraction stuffs. Okay, 6.1 was simplifying. And I think multiplying and dividing. 6.2 was adding and subtracting. 6.3 was those complex ugly fractions, and 6.5 is the solving equations. It's all stuff you need to be able to do. Practice in My Math Lab, get your homework done. Be ready to go. So we only had to cover 2 lessons, and I talked kind of fast. If you need to go back and watch this video, remember you can slow it down. I'm going to go ahead and stop the